Okay, uh, we are currently working on marketing analytics with R. Today we are going to focus on statistical test using chi-square test. The reason why we do this one is to understand uh, whether there's any significant difference between two categorical variables, two or more categorical variables. That's the reason why we are going to learn today how to do how to run a chi-square test. Uh, let's talk about uh, the properties associated with this chi-square test. Chi-square test is a non-parametric test. What I meant by this is, we are not using uh, population parameters to capture statistics and do our test for us to generalize to the entire population kind of thing. So it is not a parametric test. Chi-square test actually helps determine if there's a difference between categorical variables. So our focus is going to be in this short video is to focus on the categorical variables. So chi-square test actually is helpful for you to for one to use a test, significant test on categorical variables, and this helps determine whether differences are real or might instead be due to minor variation, like a noise, or we call that sampling error. So we are trying to understand, even though we see there is a specific difference by the specific numbers of two variables or two or more variables, we want to find out, running this chi-square test, if it is the difference is not really significant. Chi-square operates on a table. That's something that we need to remember, because when we use our programming, the first thing that we're going to do is we're going to create tables. So using the table and nested on the rest of the coding, we're going to run this test. Chi-square uses actual and expected frequencies. So essentially what we are trying to do in this test is to understand if there are two groups or categorical variables, what their frequencies are, and if those frequencies are actually statistically significant. That's what we are going to look at. So the test will run on two areas. One is the actual values and the expected values. Say, for example, actual values will be the observations that we have already recorded in our table or data frame. Expected one is the way how the investigator or the researcher would expect that to happen in some way to determine the significance of the differences. So one other critical thing that we do here is we have to develop hypotheses. So the null hypothesis, when you run a chi-square test, is essentially going to be frequencies of factors are uniform, or in other words, there's no difference. Alternatively, the alternative hypothesis is going to be the frequencies of factors are not uniform. Uh, uh, that's the alternative hypothesis is going to be. In other words, you can say actual frequencies are equal to. If you try to put it in a different way, different perspective to null hypothesis, it is all about actual frequencies are equal to expected frequencies. That's going to be our null hypothesis from a different perspective. So we need to set the p-value, that is the cutoff value, which will be helpful for us to determine whether the test is significant or not. In this, that there can be so many levels that one could use, a researcher you could use, from 5% to 10% to 1% to whatever the range that you would like to use. But for this test, I'm going to use 0.05, which is the 5% p-value. That's what I'm looking at. So if the p-value is the p-value that we're going to yield from the test is going to be less than 0.05, we could conclude saying that there is no evidence to accept the null hypothesis. The flip side is, or the other side of the same argument is, we reject null hypothesis and we accept alternative hypothesis. We don't technically say that, but this is the other side of the argument we're going to make. Okay, let's move into our area of the test. So what I'm going to do is here, I am going to import a data set from this external source, right, from website. So, and I'm going to name that data set as customer segment, CUS-SEG, customer segment underscore SEG. I'm going to use the read.csv function to import this data set from this external website. So I'm going to run that code. You can see that we have downloaded this data set, and I'm going to take a look at the the top few observations along with the columns by using the head function, and this is what you will see. If you look at the console, you will see the age. This has age variable, gender variable, income variable, kids, how many kids are there of a customer, whether they have the ownership of the house or the home, whether owned or not owned, and then the subscribed status, whether they have subscribed, yes or no, and what type of a segment they belong to. So let me take a look at another side of the above data set by using the tail function. Tail. This is the bottom part of the entire data set that we imported. I see the same thing. There are no missing values that I can see. One good thing for me to do here as a data scientist, I would like to call a library to call the data package called site. So I'm going to call that package by using library function. Let's run that one. It is already downloaded. Now let's use the describe function to see more details about more insights about the of this data set. So I'm going to use describe customer segment data set. I can see that this age, gender, and income, most specifically income, that we're going to use. This is a numerical variable. You can see the numbers over here in terms of the total number 300. That's the number of observation. The mean value of this age variable, standard deviation, median, trimmed value, MAD value, which is the mean absolute deviation, the minimum, maximum, the range, skewness, kurtosis, and standard error. Okay, what we are looking at over here is any value. If you look at the skewness, any value greater than 0.5, we can say that it is highly skewed, and you need some data cleaning or normalization strategy use on that. Okay, so that's how you take a look at what this data set is about. Now we are going to answer a question, typical question. based on this data set. So the marketing question that I'm going to answer is, let's say marketing, oops, marketing question that we're going to answer based on this to run this chi-square test is whether the subscriber type are significantly different. That's the marketing question we are going to ask to run this test. So if you pay attention to this one, we are looking at the subscriber types. So that is a categorical variable. That's what we can check that also. If you run if you use structure of the data set, you will see that subscriber is a character variable or categorical variable. See, there are about 4 levels here. So that's why we are using chi-square test on this, because this is a categorical variable. So let's answer this question. How do you answer this question is, you have to use a process. Step number 1, you have to use a table. So I'm going to use the table function on customer. I'm calling the data set. You use the $sign to pick a specific variable, which is subscribe, and let's create this table. Now you can see there are 260 subscribers and 40 subscribers. So by looking at these two numbers, you can see there's a clear difference. But we want to find out if these two numbers are statistically different. So how we're going to do is we're going to call this chi-square test, which chi-square test, all the way down, and then I say table, same line I'm going to write subscribe. If you run this one, you will see in the console that, even though we see this visually, there's a clear difference between non-subscribers 260 and subscribers 40. We want to find out if this is statistically significant. So what we're going to use as the cutoff point as p-value, which is 0.05. Now this tells this is 2.2 times 10 to the power of minus 16. That tells us this is the number that we are looking at, p-value, and it is much lesser than 0.05, the cutoff point that we set. These are in exponents. These are indicated in exponents. So what we are trying to tell here is, since the p-value is less than 0.5, we have to reject the null hypothesis. In our case, the null hypothesis is there is significant difference between the subscribers. The difference between the subscribers and non-subscribers is significantly different. That's what we are trying to establish as an argument here. So I hope this helps. If you want to run a chi-square test to understand if the subscriber types are equal or not, and how significant is that in terms of statistically significant is that test. That's what we are trying to say. I hope this is helpful, and hope to see you with another quick video. uh, with another statistical test to understand the differences between categorical variables. This focuses on the frequencies of differences. The next one I am thinking of doing to do a test to understand if there's a statistically significant difference between between the proportions by using a different test. Until then, see you later.